So you should be on page 9 here. We're going to talk about section 6.3, where it says students will be able to use properties of rational exponents to simplify expressions and rational exponents. So mainly, this is an Algebra 1 review. We are going to talk about the properties of powers of exponents. That's our big topic here to start off the day. And if you've noticed, we're also going to talk about this is what problems look like back in your Algebra 1 days and how there's a little bit of a shift, a little bit of rigor to it when it comes to the Algebra 2 example. What we need to change. Even if the problem starts to look a little weird, the rules stay the same. And that's what we have to be ready for, not to get thrown off by the way it looks. Just follow the basics and you should be okay. All right, so we're going to be doing a lot of highlighting here, so have your stuff ready as usual for many of you. All right, so first one. First property is the product of powers. The main thing to look at is, one, they have the same base. So this one has a base of A. This one has a base of A. But the idea is that when they have the same bases, well, the rule for powers are different. I write my base once, and then, of course, as you can see it here, you have to add your powers, and that's the big idea for this one. We are adding our powers, so that's our little note we'll write to ourselves. But again, we have the same base. That's the key. Same base, so we add powers. That's the rule we had to learn back in Algebra 1. And of course, when I apply it to this first little easy question here, the mistake that people in Algebra 1 make is they go, oh, I have to do 5 times 5. No, you don't. Order of operations says powers are first. So instead of writing 5 times 5, I literally write the base down again. And like we said, all I have to do is add my powers. And so we get 5 to the power of 9. Now that's a big number. We'll just leave it like this. But you can always use a calculator in case they need you to do that on BIM. You would just toss it into your calculator and go from there. Well, look at the Algebra 2 example. Very similar. We have the same base. Well, I should never write the same base twice. I'm just going to write it once. So here's that same base. But look at your powers. Your powers say a power of 1/2. Your power says a power of 3/2. But we talked about that. We know they mean radicals, but the rule hasn't changed. All I'm going to do is take the 1/2 and add it with the 3/2. And what's 1/2 plus 3/2? Well, it's 4 over 2, right? Officially. But then what is 4 over 2? So 5 to the power of 2. Now that one's small enough that we can do this easily. What's 5 squared? 25. Now, we don't know which part they would want on BIM. We're just going to put a box around this one because this is where we're testing our rules. So again, just because they start using fractions, don't let that throw you off. The rule says add powers. Well, then add your powers. We don't care how weird the problem looks. The next one, of course, is the power of a power. These are the two rules that people mix up the most. See, here we only see one base, not two of them. That's why they only write the base ones. But what we have to notice is when I look at my powers, there's a power of m and a power of n. When you have one base but two powers, well, what does it mean when you write them right next to each other? What does it mean when you write them next to each other? Multiply, that's it. So we multiply powers. But these are the two that people sometimes struggle with. They always forget, well, do I multiply or do I add? Well, look at the bases. You only have one base with two powers. That's automatic multiplication versus having two bases with a power each. So we do have to distinguish them. And so here, normally we would say, hey, according to order of operations, I should be working on the inside first. But we're going to practice the rule. So I'm going to copy my base down. There's my base 3. And the rule says all I'm going to do is multiply my powers. So what is 3 times 4? And there's my answer. 3 to the power of 12. That's, again, a big number. If BIM wants an actual value, you throw that into the calculator and get the answer. But for now, we're just talking about rules. And then there's this. Again, people see this and go, oh, yeah, that fraction. I don't know. This is different. It isn't. There's one base. Then I'm going to write my base down. So there's my 3. What am I supposed to do with my powers? Multiply, then go 5 over 2 times 2. Now, what could I put underneath this 2 right here? A 1 under it if it helps. And then because you're multiplying, well, what happens to your 2's? See, you're doubting the basics. What are you supposed to do with these 2's? Cancel them out, leaving you with a base 3 to the power of. See, and that's it. That problem is officially done. I don't know what 3 to the 5 is, so we'll just leave it like this because the idea is we're practicing the rule of the day. Okay. Next algebra rule from your past. What if you have a power of a product? So that means you got a power on the outside, but you have one base and you have a second base. So we have 2 bases. Oh, missed it completely there. We have 2 bases with the power on the outside. Well, what did you notice they did with the power on the outside? Yeah, it's like distribution. Everybody gets their own power is the idea that's outside. So that'll be the little note that we write here. It's like distribution. You can think of it that way. Note though, the only reason I can do that, do you see a plus or a minus on the inside? That's why I can do this little distribution of powers. But the idea is everybody, or everything we should say, everybody gets the outside power. Now, according to order of operations, I should be multiplying the 3 and the 4. We should be doing that first. But just to show you the step, this idea that we just talked about, technically I'm supposed to do this, right? I should be multiplying, but I'm supposed to write the 3, I'm supposed to write the 4, and then each one is supposed to get their own power of 2. If I'm applying this rule. Well, what's 3 squared? 9. What's 4 squared? See, now I can just multiply that and then get an answer if we wanted it, which I believe is 144. But that's the idea. Everybody would get their own power of 2. But like I said, normally I would have just said 3 times 4. And what's 3 times 4? To the power of 2? Say 144. Same thing. So it doesn't matter which way we go. And that's the nice thing about math is the fact that we can give you a bunch of different options, but we'll all get the same answer if we do it correctly. And then there's this one. Now, again, I could multiply the 16 times the 9. I could do that. But I know the number 16 is a perfect square. I know the number 9 is a perfect square. And why am I bringing that up? Because when I see this, power of a fraction, it means it should officially be a radical. So when I'm looking at this problem, I'm thinking, all right, well, the 16, I'm going to give it a 1/2 power times the 9, which I'll also give a 1/2 power. And because I see a power that's a 1/2, it means it used to be a radical with a 16 inside. And then what's the index? 2, right? It's already there, so I don't even have to write it. Over here, a power that's a fraction means it used to be a radical, and it's an index of 2, so I don't write it. But you see, I can do it this way. I recognize that 16 and 9, they're small enough. I can do square roots of them. I already knew a square root was coming because of this right here. I knew it was going to be a square root, so that's why I held off on multiplying. What is the square root of 16? And the square root of 9, which means the answer is 12. Or I could have just multiplied and then just do 1 square root. So there's a lot of options. But I'm trying to just apply the rule. All right, and then we did talk about this one not too long ago. We said negative exponents. Remember, all of this is in our word wall. We have a box for every single one of these that reminds you what to do with them. So some of the stuff we're adding here, Maybe you need to transfer that into your word wall so that it guides you a little bit better. But when you have a negative exponent, and we're talking about the negative m right here, so there's my base. There's my base. But when we say a negative exponent, right, a negative power, we're talking about that right there. Well, there's your m now. Notice, does the m have a negative power anymore? No. Why? Because we change its location. And that was the big thing we needed to remember. That when you have a negative exponent, all you have to do is change location in fraction. And if you're thinking, yeah, but I don't see a fraction, well, then create one. Very simple. You just put a line. So what we were talking about in class last week, we said, look, I could put a 1 under this. So the a is at the top of a fraction technically. Well, the negative power says move it to the bottom, so we move it to the bottom. And when you make that move, that negative disappears. So that's why here on this one, yeah, I see a negative power, which means the 4, which is currently on top of a fraction, now needs to go at the bottom. But what's the new power? 2. Yeah, the negative is gone. And when there's nothing left on top, well, we just put a 1 on top. Just like I put a 1 at the bottom, we'll fill in that empty spot with a 1. And then what is 4 squared? But the 16 is still at the bottom because, well, that's where your 4 squared is. And that would be my answer to this problem. So again, we're going to have to practice every little rule about negatives. And the SBAC, those first few questions they give you on the SBAC have no calculator. They're going to ask you a lot about your power rules and understanding those basics that come with it. So even this one, you might say, yeah, but it's a power that's a 1/2. Yeah, we don't care. The fact that this is negative means that the 36 should be written where? The bottom of a fraction. So there's my 36, and what's its new power? What's the new power for the 36? Yeah, 1/2. The 1/2 doesn't disappear. It's still there. It just doesn't have a negative anymore. But on top, of course, we just put a 1. But what does a power of 1/2 mean? What is it telling me to do? Square root it. And it is a square root because of the 2. So a power of 1/2 is an automatic square root. But what is the square root of 36? And there's my answer. Okay, clarifying question so far. Remember, it's all word. Okay? All right, what color have I not used? Okay, 0 exponent, everybody. Meaning, what do you do when you have a power of 0? Yeah, here's the reason, again, if you need to see it. I believe I talked about it before. Maybe not, I can't remember. So let me ask you this. SBAC is all about basics. So if I say a to the 3, what's the meaning of a to the 3? Thank you. Basics. A times A times A. You have to know what powers mean. It means write me down this many times. So then what is the meaning of A squared? A times A. What's the meaning of A? Well, first of all, what's the invisible power? 1, which means what's the meaning of A? A. Right? Write me once, it says. So then what's the meaning of A to the 0? Yeah, so am I supposed to write a letter A? No. But what we've learned is that, yes, we always talk about invisible numbers, right? Well, what's the number in front of the A? A 1, because it's invisible, but we never write it, but there's one there. There's a 1 here. They're always there. Even this one has a 1 in front. Well, then that means if you're being told don't write the A, well, then I still have to write the 1. And that's why anything to the power of 0 will always give me a value of 1. So that's what this note is saying, that anything to the power of 0 will always equal a 1. Okay, and man, you can put it in words if you need to. So what's 213 to the power of 0? 1. Oh, look at this ugliness. 5,213.54 to the power of 0. 1. SBAC loves to give power zeros. Why? Because they know students overthink it. Let me show you a different one that you've seen on the SBAC in the past. We've seen people get this question. 5 over 10. Yeah, that can be reduced. X to the third, x to the 4. Yeah, we should reduce that too. Y to the third over y to the fourth. Yeah, that should be reduced as well. And then they do this, which means what's the answer? 1, done. Why? Because they know people are going to go, yeah, I could work this out. I can do this. And hello, power 0. Everything is a 1. Stop wasting your time. So we got to watch out for those powers of 0. Okay? Especially with the SPAC. All right. Well, two more rules here. So the next rule says quotient of powers. Remember, you have to know when to add them. You have to know when to multiply them. And of course, if you look here carefully, yeah, they have the same base, but you only write it once. And then you take your powers and we subtract them. So we have to know when to add them, multiply them, or subtract them. The only thing that this doesn't say, and it would probably be a good note here and in your word wall, okay? You got to keep, so you have to keep the base where you have more. And I'll explain that again in a little bit. So when I look at this problem, there's a 5, there's a 5, they have the same base. This one has a 4, this one has a 4. Great, same base. That's why this rule can be applied. But I am definitely not adding my powers. I have two bases, so I know it can't be multiplication. Where do you have more 5s, top or bottom? Top, then I don't need a fraction. I'm just going to write the 5, and then what's 6 minus 4? So there's my answer. Now, if it's something this small, we should just say 25, right? But the idea is that's how I would apply the rule, even for these weird ones. 5 over 2 and then 1 over 2. Then where do I have more 4s, on the top or the bottom? The top. Then I'm going to write the 4, but then I'm going to go 5 over 2 minus 1 over 2. What's 5 over 2 minus 1 over 2? And what is 4 over 2? 2. So there's my answer, or we could also just say what? 16. So we have to know our powers of 2. Don't let them throw you off just because you see fractions over here. They're powers. The rules still apply, even if they look weird. Which brings us to the last one. The power of a quotient. Well, look, we only have one power. And yeah, I have two bases. I've got an A here. There it is. I've got a B on this one. There's another base. Well, there's a base. So it is very similar to the other rule. If you have two things inside and there's a power, then who gets it? They both do. Everybody gets the power. So just like last time, okay? Everyone or everything gets the outside power. Remember, PEMDAS still applies. The please excuse my dear Aunt Sally concept still applies here. And so when I see a problem like this, yeah, there's a 3 and a 6, but you should already look at that and go, oh, I can reduce it. So I'm not going to worry about the 2 yet. You should be reducing the 3 and the 6. What does 3 over 6 reduce to? Yeah, it's just a half. See, now I can do this. I'm going to give the 1 its own little power of 2. I'm going to give the 2 its own little power of 2. And now I can actually do the problem. What is 1 squared? And what's 2 squared? There's my answer, 1 over 4. Remember, if they're numbers, you should try to reduce them as much as possible. Same thing on this one. 36 and 64, they're both even numbers. So take a moment and see if you could reduce that. I don't want to give it a power of 1/2 yet, especially if I can reduce it. Maybe I'm going to do that on the next step, and I'm letting you know you can reduce it. And then I'll do this to it, which I know this one still has more steps, but that's the first thing. So what is 36 over 64 reduced to? Say it again. 9 over 16, okay. Which now means everybody can get their own little 1/2. Again, basics. Don't overthink stuff. I reduce. Okay, that's a basic rule. Everybody gets the power of 1/2. Okay, let me write it out. Let me visualize it. Well, there's still a fraction. What does a power of 1/2 mean? Again, this is now a basic rule for us. Power of 1/2 means. Okay, I heard that. What does a power of 1/2 mean? Square root. And same thing down here, square root. So right now I'm gonna do a square root of 9, and then I'm gonna do a square root of 16. Well, you know those numbers. Square root of 9 over, and just like that, there's my answer. So the thing about this table that we created, one was to review our power rules, but now you're going to see the type of question they're going to throw at you, because they're not going to test you on one little rule at a time. No, they're going to bring them all together and try to get you. So we're not going to fall for those tricks. We're going to do things very carefully. We're going to take a moment with example number 1 here, and we're going to apply these rules. Use the properties above to simplify the expression. For letter A, I already see the one thing I have to take care of first. So, Jonas, what am I going to take care of in letter A first? Yeah. See, I've got 1A. That's great. But should you have a problem with 2 of the same letter? Yeah, never. Yeah, there's a 4, but I'm not ready for that. I'm going to take care of the inside first. So right now, I'm going to leave that 4 just patiently waiting out there. The A was already done, so let me write that down because I didn't need to do anything to it. There's the A. What I needed to take care of was the B. And how many times, Jonas, will I be writing the B? No. How many times will I write the letter B? Once. But notice how he said an 8, because what am I supposed to do with my powers right up there that you could barely see? Add them, and that's how he came up with his 8. So you have to add your powers. So there's the rule number 1 that we already applied. It's a little bit messy here, but we added powers. So we got that 8. Now I have one of each letter. Well, now that I have one of each letter, I'm going to apply the next basic rule, which is everybody, this one, they all get which power their lyric. What power do they all get? Two. Where's there a 2? 4. Everybody gets their own 4. That's the next thing I look at. Well, there, everybody got it, which now means I can do everything individually. So here's my A, there's my B. They should be right next to each other. We don't need them separated. But now it's all about the power. So Christian, what am I supposed to do with these powers right here? Add. All right, if you look at the note up here, this is what adding power should look like. I have 2 bases, A and A. I don't have an A and an A. Multiply. So what's my answer here? 12. What am I supposed to do with my powers here, Emily R? Multiply them again, which is why we get 32. That's my answer. And again, that's the toughest thing for many. You have to be able to separate the rules from each other. The rules for powers are very different than for regular numbers, but we have to attack one basic step at a time. Okay? Now let's try it again. Now look at this one. 125, which has a power of what? 1. Okay. And do they both say 125? Yes, they do. Well, then, where do you have more 125s, on the top or the bottom? Top, because this is a whole. This is a fraction of something. So I'm going to write 125. And then what will I be doing with my powers? Subtracting, which is 1 minus a third. Well, we don't subtract that kind of number. I should be changing that number 1 into something else. So there's my 1/3. See, this is the issue right here. But what can the number 1 be turned into? 1/1. What else can it be? 3/3. What else? Give me another example. 5 over 5, 7 over 7, 10 over 10. The number 1 is the best number because you can turn it into anything you want as long as they match, right? Negative 2 over negative 2, negative 3 over negative 3. Well, what's the best choice for this one? Because at least the denominators match. And that's our elementary teachers told us. You add and subtract fractions, you better have the same denominator. Now I'm ready. This is 125. And what's 3 over 3 minus 1 over 3? 2/3, which means this thing is officially a radical, and not just any radical. What root? 3. That's my third root. What goes inside? 125. And then, of course, it all has a power of 2. Now, if they wanted you to work this out, you could have just tossed that into the calculator. I do believe it becomes 25 as a final answer. I'm out of space, so I'm just going to tell you, but it does become 25. The cube root of 125 is 5, and when you square it, 25. Okay? All right, and then here's the one that we see a lot. Many of you that take the SBAC will be getting a question like this in the beginning of the test. And it's weird because we've also seen people get this question at the end, be like the last question they get. And it's because at that point, people are so tired that they overthink it. What is it that they want me to do with this and this? Multiply, that's it, it's just multiplication. Well, what we've told students, and this is what we do with our freshmen in Algebra 1 when they learn it for the first time, numbers with numbers, right? In fact, look, I'm going to go very old school on you. Letters with letters, so letters with letters. And notice how I am separating every letter on its own. This is what we show our Algebra 1 students when they learn this for the first time. But look, numbers with numbers. 3 times negative 5. X to the 3 times x. Y squared times y4. If you learn to just separate everything and look at it as one thing at a time, all right, well then, do the math here, Fernando. It says 3 times negative 5. Negative 15. All right, well, there's an x next to it, so there's my x. And Kayla, what do I do with my powers here for the x? So that's a power of 4 because there's an invisible 1. And we add, and then I write the y right next to it. And then Renata, what's the power for the y? 6, because what did you do with your powers here? Add them. There it is. There's my answer. Okay. Questions or concerns? I know there's some you tries, but I need you to flip it over because there's a couple more examples there with you tries there. So it's interesting. Yeah, let's go to the back. I'm going to do a few of those, and then you'll do the rest as you tries. So we're going to do 3 more, okay? The bottom ones are your you tries here. So you have 6 you tries when we take our first pause in the notes. So it says, keep using the properties. All right, when I look at it, look, base 3, base 3. Easy. So that means, where do I have more 3s? The top, then just write a 3. And what am I supposed to do here, Violet, with my powers? Subtract them, and what's 15 minus 5? So then it's 3 to the power of 10. That's a big number, so we're just going to leave it like that. Done. By the way, all these 6 here, we've seen them on SBAC. That's why they're here, just so that we can start showing you what they look like. Yes, believe it or not, people get questions like this on the SBAC. It's not meant to be difficult, right? Stick to basics, you'll be okay. Ooh, what do we not like in letter H? We don't like negative powers. You got to fix that, right? Always fix. Always fix negative powers. We don't like them. Fix them. So right now, I'm not going to do any math. I'm just going to take care of, put things where they really belong. All right, 3 to the 3. Does that have a negative power? No. What about the 4 underneath? I'm just taking care of numbers right now. Does a 4, so then where should the 4 go? On the top, so I'm going to go times 4. All you have to put is just little dots between them. Again, that took care of my numbers. Numbers with numbers. All right, let's talk letters. When I look at the first X on top, does it have a negative power? Then where does it go? To the bottom. All right, write it at the bottom. And it's now a power of 4. What about this x right here? So then where's it going? To the top. Okay. And, ooh, what's y to the 0? So should I even write it? Oh, cross it out. It's just a 1. You don't need it. This is the real math then. So then handle one thing at a time. See, I'm going to write my fraction just in case I still need it. Maybe I won't, but we write it. What's 3 to the power of 3? And you better not say 9. It's not 3 times 3. It's 3 times 3 times 3 again, which is 27. Times 4, right? Because I'm not ready for that one yet. All right, but where am I writing x? The bottom. You better not write it twice. You have to write it where it's bigger. And what am I going to do with these powers? Subtract. They're not side to side. So then I'm going to go 4 minus 3. Notice how I wrote the 4 first. That's why I chose the bottom, because that's where the bigger number was. And now let's officially finish it. You might need a calculator here. What's 27 times 4? If not gold school, look, 27 times 4, 4 times 7, 28. 4 times 2 is 8, 108. And where am I writing the 108? In the top, because that's where my numbers were. Where am I writing my x? And what's the new power? So I don't even need to write it. There's my answer. You might say, man, but I could have done this a lot faster. Okay, great. But I don't skip steps. One, because I don't want to lose some of you, and I'm playing it safe, especially when the SBAC, the test comes in. We're just playing it safe. Okay? All right, last one. What do you notice again? Negative powers. Okay, we got to fix that, which means that power of 2 is currently on hold. I don't have to worry about that 2. I'm going to take care of the inside. I'm going to take care of it one at a time. All right, here we go. Does the 3 have a negative power? Then leave it alone. Does the negative 6 have a negative power? Where's the power? I didn't ask, is the 6 negative? I said, does the negative 6 have a negative power? Okay, what power does it have? Because it has a power of 1. That's all it has. The 1 isn't negative. Then leave it alone. That's why we like showing you this problem. People think, but it has a negative in front. We didn't say about negatives in front. We talked about negative powers. The number's done. Let me go to the next letter. Does x to the 3 have a negative power? Then where is it going? Or where do I write it? On the top. You don't mess with it. Does the x at the bottom have a negative power? Then where's it going? To the top. Okay, put it to the top. All right, what about the y? Does the y have a negative power? Yeah, so where's it going? To the bottom. And does the other y down there have a negative power? Oh, then leave it alone. Basics, everybody. It's when you rush through and go, nah, I can just do it faster. All right, get the mistakes coming. One thing at a time and you won't have an issue. So now can I work with this power of 2? No, you still have too many x's, you have too many y's. You shouldn't be having that many. And that power 2 is still on hold. All right, well, numbers first. What is negative 3? Sorry, what's 3 over negative 6? Yeah, it's 1/2. Well, negative 1/2, because negatives just go in front or the top. Well, you said all the x's are on the top, so I'm going to write x at the top. But what will I do with my powers? Add them. So what's my new power? 7. My y's at the bottom. Well, let me write it at the bottom. And what's the power going to be for that one? 6. Now we're ready. Now everybody can get that power of 2. And even though it seems like, man, Mr. using up a lot of space, well, playing it safe, look. Negative 1 gets a 2. X to the 7 gets a 2. At the bottom, the 2 gets a 2. The y6 gets a power 2. Everybody gets it. Not just, oh, but the 2 and the y. Yeah, separate them, though. Because now, look, what's negative 1 squared? 1. What's 2 squared? 4. Now, I don't write 1 for a reason. There's a letter up there. I don't write invisible 1. What am I going to do with my powers now? Come on, basics. This can't be what gets you. Whispering, let's go. What do I do with my powers here? So what's 7 times 2? 14. My y's at the bottom. Write it at the bottom. And what's 6 times 2? And there's my answer. You got to stick to basics, but you have to know those basic rules. That's what today's about. All right, so you have 6 you do's. Go back to the first page, and then you're also going to attack these 3 at the bottom where they're testing you, and these are the S-spec ones. So, all right, go for it. Give it a try.